Dear students, in this section we will consider hypothesis testing in the context of regression coefficients. In the last class, we have discussed how to test hypothesis using confidence interval approach and test of significance approach using arithmetic mean as the estimator. Now we discuss in detail hypothesis testing in the context of regression analysis. The parameters of our discussion are beta 1 and beta 2. The estimators are beta 1 hat and beta 2 hat. We use these estimators to make inferences about parameters. As I discussed in the previous classes, remember this, before estimating a model, you must formulate hypothesis about beta 1 and beta 2. That is the first step in any hypothesis testing, in any empirical research, whether it is economics or any other social science. Once the hypotheses are fixed, we collect data and using the inferential procedures, the steps in hypothesis testing discussed earlier, we test a hypothesis. We fix the level of significance alpha. We fix the critical region based on the alternative hypothesis. We choose the test statistics depending on the problem at hand. Then we calculate the value of the test statistics from the sample, compare it with the critical values and take a decision. All these we have discussed in detail. Now, as I discussed in the last class, there are two approaches to hypothesis testing: the confidence interval approach and the test of significance approach. Now, as we have discussed earlier, the question in hypothesis testing is a given observation or finding is compatible with a stated hypothesis or not? That is the fundamental question which we ask in the context of hypothesis testing. Is a given observation or a finding, sample finding, is compatible with a stated hypothesis or not? Compatible means sufficiently close to. Compatible means sufficiently close to so that we do not reject the hypothesis. We do not reject the stated hypothesis. And if it is sufficiently close to the stated hypothesis, we do not reject it, otherwise we reject it. In the language of hypothesis testing, the stated hypothesis is the null hypothesis tested against the alternative hypothesis, also known as the maintained hypothesis or the research hypothesis. And the theory of hypothesis testing is concerned with developing rules or procedures for deciding whether to accept or reject the null hypothesis. Whether to accept or reject the null hypothesis. And as I told you earlier, there are two approaches to hypothesis testing: the confidence interval approach and the test of significance approach. In both of these approaches, that is in the confidence interval approach and also in the test of significance approach, we assume that the estimator is a random variable and the estimator has a probability distribution, and the probability distribution of the estimator is known as the sampling distribution, and the sampling distribution is used for hypothesis testing. Let me repeat, for hypothesis testing, sampling distribution is used, population distribution is not used, and the normality assumption we have stated earlier is used for hypothesis testing, because if X is normal, estimator is also normal. And in the context of regression, we assumed that U is normal. And as estimators are linear combinations of U, estimators are also normally assumed. We will not say anything about the dependent variable X or independent variable, the dependent variable Y, independent variable X to determine normality. So, first we consider the confidence interval approach. Now before that, both our approaches are based on an example. This example is taken from Basic Econometrics, Damodar Gujarati, which we have discussed in the beginning, the consumption income example. Income starting from 80 to 260 and consumption also, and N was equal to 10. N was equal to 10. Now, using OLS, suppose that the estimated model is Y hat is equal to Xi, standard error of beta 1 hat is 6.4138, 0.0357, and N was 10, degrees of freedom is 8, alpha we fix it as 5%, and the critical t value is equal to 2.306. Critical t value is 2.306. Remember this. In the discussion of regression analysis, we will consider only t values because the standard errors are estimated standard errors. Because the standard errors of estimators are unknown, we use the estimated standard errors. So we will not explain hypothesis testing using Z. Our discussion is based on t distribution. So N is 10, degrees of freedom is 8, alpha is fixed at 5%, t, critical t value for 8 degrees of freedom and 5% level of significance is 2.306. Now let us see the confidence interval approach. First, we explain this with respect to the slope only, beta 2 hat equal to 0.5091. 0.5091. Suppose that our hypothesis is H0, beta 2 is equal to 0.3, tested against H1, beta 2 not equal to 0.3. While formulating hypothesis, always keep in mind the principles we have discussed. And I will discuss more about hypothesis formulation later. I just imagined a value, that is all. Our hypotheses are based on previous empirical work, the problem at hand, and many other considerations. It depends on what we are trying to understand. And it varies from one situation to another situation. For the time being, I assume that beta 2 is equal to 0.3, tested against beta 2 not equal to 0.3. This is not the only hypothesis we can test. We can test many other hypotheses, and we will discuss this in detail later. Now, once we formulate the hypothesis, sample is taken, the model is estimated, and we construct the 95% confidence interval for beta 2 as beta 2 is equal to 0.5091 plus or minus 2.306 into standard error is given 0.57. So you will get it as 0.4268 beta 2 less than 0.5914. This is the 95% confidence interval for beta 2, that is 0.5914, 0.4268. 4268. Now, in the language of hypothesis testing, if beta 2 under H0 lie in this interval, if beta 2 under H0 lie under this interval, the interval is 100 into 1 minus alpha percent, that is 95%. Alpha is fixed at 5%, so 95%. We do not reject H0. Otherwise, we reject it. And as you can see, the hypothesized value is 0.3. 0.3 is not in this interval. 0.3 is outside the interval. Somewhere here, outside the interval. So we reject H0. That means our sample is not generated by a population with a mean equal to 0.3. And so the procedure is, so the confidence interval approach to hypothesis testing is like this. Construct a 100 into 1 minus percent alpha confidence interval for beta 2. If beta 2 under H0 falls in this region, do not reject H0. Otherwise, reject it. And as we have discussed earlier, the parameter will lie in such intervals 95 out of 100 times. 5 times the parameter is out. Actually, the parameter may be out. That is, this sample may be generated by a population with a parameter different from this, maybe a parameter equal to 0.3. That is, the parameter is outside the interval, but we do not reject. That means we will be making a mistake 5 out of 100 times, because the parameter will lie in such intervals only 95 out of 100 times. Now, this is the idea behind confidence interval approach. Construct the 100 into 1 minus alpha percent confidence interval and see whether the parameter is within this interval or not. If the parameter is in this interval, do not reject H0, otherwise reject it. In our example, the hypothesized value is outside this interval, 0.3. So we reject H0. That is, our sample is generated not by a population with a beta 2 equal to 0.3. Beta 2 is equal to 0.3. So this is the idea behind confidence interval approach. Now, in the language of hypothesis testing, when we reject a null hypothesis, we say that our finding is statistically significant. And when we do not reject H0, we say that our finding is not statistically significant. So in this case, as the null hypothesis is rejected, our finding is statistically significant. If our hypothesized value was within this interval, we do not reject H0 and our finding will not be statistically significant. When we say that statistically significant means our sample finding is significant, our test statistic is significant, and test statistic is based on sample. So our sample finding is significant. While, as I told you earlier, in the case of a court procedure, the evidence collected by the police is used to verify whether a person has committed the crime or not. If the court accepts H0, it means the person is innocent. That is, the evidence is not significant. Similarly, in our case, our evidence is the sample. Sample is used to accept or reject a hypothesis. If H0 is accepted, our sample finding is not significant. In this sense, we say that the test statistics is not significant. If H0 is rejected, we say that the test statistics is significant. When we reject a hypothesis, we will be rejecting a true hypothesis 5 out of 100 times, because the parameter will be outside this interval 5 out of 100 times. Parameter will lie in intervals like this only 95 out of 100 times. 5 times the parameter is out, but still we reject H0, even though H0 is true. So reject H0, H0 is true is type 1 error. Reject H0, H0 is true. That is type 1 error, and alpha is the probability of committing a type 1 error. And this is the confidence interval approach. Estimate the parameters, calculate their standard errors. Using the standard errors of the estimators, construct 100 into 1 minus alpha % confidence interval. And if the hypothesized value is in the interval, accept H0, otherwise reject H0. When you reject H0, you will be rejecting a true hypothesis 5 out of 100 times, because the parameter will be in such intervals 95 out of 100 times. 5 times the parameter is true. Again, you are rejecting a true hypothesis. So the probability of rejecting H0 when H0 is true is 5 or 5%. That is known as the level of significance.